What we are going to talk for today, it's about one part of MATLAB software. As we lecture before, I tell you that please install the MATLAB. Now this is the time that we can review some theoretical part that we study, as well as start to work with one of the toolbox in MATLAB. Again, I will share one webinar about this toolbox, and we will talk regarding the part that we need. Actually, these toolbox is very vast, and there are so many um, considerations, so many parameters when you want to work with this toolbox. I don't want that you learn all these toolbox, but some essential part which we need. We will review during the lectures, and obviously we have some task on that you will learn how to work with the image processing toolbox. As you know, MATLAB was abstract from the matrix library, and as a high-level language, it's well known, which has the interactive environment that can give this ability for you to do the faster uh, computation job and calculating job, as well as um, doing the mathematical equation with the good speed compared to C, C++, and Fortran, which was more demand at 20 decades before. MATLAB, we can call it as an interactive interpreted language, and that is designed for the fast numerical matrix calculation. And lots of work and research work, as well as industrial work, are carried out with hiring these software. Inside the MATLAB, there is lots of uh, toolbox. One of them, which is related to our subject, is image processing toolbox. This toolbox is something like the function that extend the capabilities of the MATLAB's numeric computing environment, and it support the wide range of image processing operation, something like geometric operation, linear filtering, filter design, transform, image analyzing and enhancement, binary image operation, region of interest operation, and so many parts which released from MATLAB is extent. In this toolbox, um, we have some special image transformation, some morphological operation, neighborhoods and block operation, linear filtering, and as you see, some parts I bring here for you, which is related to our subject. Many of the toolbox function are in MATLABs are in the form of M file and series of MATLAB statement that implements a special image algorithm we have here. Um, some codes and some part we will see in this later, which is the aim of today's talk. And here you can see that, first of all, as the entrance for this MATLAB, we have, and we should see the parts in the MATLAB that as the entrance, we have the image part, which in that we can uh, review as the entrance in MATLAB toolbox. First, we should review which image format we can use and which can be applicable for the MATLABs. Some formats like BMP, GIF, HDF, JPG, PCX, PNG, TIFF, XWD, some of them maybe you know, and some maybe you don't know. I just bring the name here and some data type like double, floating, integer, 32, 68, and uniform means that unsigned integers one are used inside of the MATLABs. Something that maybe now you will understand why we review the difference between the image, which is not image format, which is not exactly inside of our course, means that the difference between BMP and GIF. That is why I give you that part as the task that you should review. Now, with this information, that the format and pictures format that we can input, we can start working in MATLAB's work. But before that, let us first review some part. One is that uh, first we should know what is binary image. As we talked before, binary image are combination with the 0 and 1 numbers, something like this. As you know, the one part is has the value of 1, and the black, I mean the white part, and the black part is having the value of 0. Another type of the image is intensity image, which has the 0 to 1, but with the unit 8 or double, uh, something like this. You know, the numbers are between 0 and 1, not exactly 0 or not exactly 1. It's something like normalized picture, which we call it intensity image. And due to the um, ratio or the numbers which we had, which is near to the 0 or near to the 1, means that near to the black or near to the white, you have the values that we call these types as the intensity image. The next one is the RGB, which we know them as the matrix of n by n with the 3. That last three is there are the three layer. One is R as the red, green as G, and blue as the B, which we know them layer by layer, and we are furnish them inside of one matrix. Suppose one example I brought here for you, that you will see that we have the combination of RGB in one color, as well as which they are formed in the in the matrix. A multidimensional image also will use as the m by n and p, which p can be the number of layers. Now you will see that we can have more than 3 layers. We can have p layer, and we can use them inside the MATLAB. Uh, the first things that we should know in the MATLAB part is that you can extend the capabilities of the image processing toolbox by writing your own M file or by using the toolbox in combination with other one, such as something like signal processing toolbox and wavelet toolbox. Why we can use these two toolbox? Because we have some concept or some nearest concept between the signal, I mean audio, video, uh, and you can use some parameter from other toolbox with this concept. I mean, really, if you want to think regarding the signal, sound and video have in some parts they are we can have some common definition between them. How uh, we can have this definition, because the nature of signal in the sound is different than video or than image, but something like the spectrum of the sound that we have can be similar to the spectrum of the color that we have in image. Something like intensity of the color, we can compare it with the attitude, with the amplitude of the sound signal, and some similarity between these two type of signal we have, which some of them are near, some of them are far, but it can help us to use the other toolbox with the aim of image processing, which maybe we will use in this lecture. Have this in your mind. And second thing is that in all the codes that we will use in image processing part or in MATLAB, two commands is usually um, used. One is clear, which is equal to CLC in C language. Another one is close all, which force any prior windows that you have to be closed. When you run these two codes, means that clear and close all, these two, you will see that your MATLAB window will become clear. And also, if you open any other windows as the output of your program, you will see that it will be closed. Uh, okay, now we have sufficient uh, information and sufficient data to start the working with the MATLAB image processing part. Because we want to work with the image part, then the first statement or the first comment that we can review is how to read or how to put or input the figure inside the MATLABs. For this, the um, uh, comment that we can use is I am read. And suppose we can start from some TIFF image, which we call it Pout .tif inside of the MATLAB. How we will do it is very simple, just one line. I am read and the name of the figure. I have some short attention to the part which I put inside the parentheses, which we call it Pout TIF here. This is actually the name of the figure or pictures that exactly I put the picture's name also here for you. You know, we can work with two type of image in the MATLAB. One is that the ready-made pictures, which I will show you. Another one is that the picture that you should use and you made it, means that it's your picture. Okay. Today we work with both of these type of pictures. One is that the ready-made one, which obviously you don't need to give them direction or you give the address of the image for the MATLAB. If you put a name, he knows where is this image and going and grab it and use inside of your code and give you the proper output. But for the image that you have it and you made that picture, you should give the address for that. We will test this. Second things that you should know about this I am read that. As you know, everything in MATLAB are furnished inside of the matrix form. And for the matrix part, you should have the name for the matrix. Okay. That is why I put I is equal to I am read. It means that whatever data that I put as the input should save inside the matrix of I. And then obviously, if I want to show it for you, and if I want to give you the output, I am show is very simple. It will give you the output and you can observe your image from that. Here, there are some image source that I found we have on the MATLABs. You will see that they are in TIF, they are in PNG, they are in JPG formats, and these are the name. And based on the various application they will use, you know, some of them are good when you want to work with the edge detection. Some of them are good when you want to test your suppose shape detection or any specific object inside, which by the license of MATLABs, they are select, okay, and they are little bit, we can say these are the standard image. One more thing that you should review that some universities, something like Cambridge and others also, they have the collection of image that you can easily download it and as the reference we'll use in research paper. Have that also in your mind. Then if I want to summarize, we can have three type of image. One is that your image, means that whatever image that you made. One is that image that we have inside the MATLAB, which they are limited, obviously, but they are very good for learning. Third one are some scientific image, or they call it image database, which is provided by the universities, and they are somehow they are free, and for some you should pay. Okay, uh, we have these three. Maybe some of you ask me why we need this type of image. You know, in image, we have lots of parameter: intensity, method, camera, some DPI, as we reviewed before. And then, if any person in research work or in industry also, they want to suppose invent some algorithm, we need to test based on some standard image, okay, and some common and standard image. Then that is why we have these three level of image that people can test. Suppose if I claim that my algorithm is faster than you, then you and me should have the same input. That is why they made the data image or data source for researcher to have the common experience and also test their algorithm and routines with some standard form. I mean, uh, the main reason for this job is to have the format that we can evaluate the others' work with each other. Then these are the part image that we have. And if suppose like me, you install 2080 version, it's in this folder format, program files, MATLAB, or as the release 2018A, toolbox image, and I'm data, you can see the list and these figures. If you are installing 2020 version, that part is changed, but the place after installing the MATLABs is same, and they are affordable for you. You can see the image. I think it's not a bad idea for you to check this routine when you run the MATLAB next time to see the various image. And please don't change them, don't rename them, because they are fixed and can be used just with the name which is assigned by the MATLAB. Okay, let us start from first command. Read and display an image means that if we want to read from the different location, what we should do. I have one picture from myself that I put it in drive F. Then simply you can give the reference of that image by the F column backslash and the name of image and format. Okay, this is one image that I take with my mobile cell. And then if you put I am A, I'm sure A, you will see this exactly like what I shown here. And this is the result after testing the code. Then the first command that we learned from IM tool is IM read and IM show. IM as the short of image. Then if you want to read it, IM read. If you want to show it, IM show. Okay, we'll do more with this. Then first command we learn. Okay, somehow it will happen that you want to know the size of this image. Then you can have the size and then whatever matrix name that you put. Here, as another example, I use one of the fixed image of MATLAB at the Apple, which is in the form of JPG. I read it and put it inside the matrix of IMG, And then I want to know the dimension. I put the size. Then I wanted to show it. Then I put figure, and then IM show. IMG means that show the figure. Then in IM right, I wanted to put it in the form of a BMP. Now you will see that in just this PPT, I'll review 3-4 comments one by one. And something which is important, that instead of IM show, you can use IMAGASC or IM tool or image like that also in some MATLAB versions. But I advise you that now initially just use the IM show. Have this in your mind. We will talk more. As we talk, every image in MATLAB or every data really in MATLAB are in the form of matrix. But suppose if I want to build a matrix uh, with the intensity image, something like that, how I should do. This is one example. Suppose we want to have the matrix of 256 by 256 as the row and column, and then we want to make all as the dark. Then simply with the MATLAB statement of zeros, you can make the matrix with the elements of zero. And then you can say that suppose for this matrix from dimension of 100 to 105, we want the value of 0.5 from in the row, and in the column, suppose for the 100 to 105, we want to have the value of 1. This white line that you see is the value of 1, and this gray line is the value of 0.5, which I shown here in this image part. Then simply you can test this code that I give you here, and you will have the same output as the result. Then this is the first practice that we will do after reading the image, that you can make the intensity image with some specific value, and with simply with this form of the command or code. Now, suppose I want to make the binary image, and but as we thought, this binary image we want it with the row and column of 256, and then if you want to make the same image that I put here, simply you can use the rand row and col, which this command will generate the randomly uh, place for your column and row, and then generate the random value to this environment, means that this matrix that you have. Again, you can have the IM show, and if you want to know the size of that, just you will put the size IM, and output is same as what I show you here. Even this binary image, or as the black and white image, which it's content of 1 and 0, um, you can make it in one more format, something like another codes that I written here. And you will see that that clear is for clearing the previous data that I had. Then you can have the matrix of 0 of 10 by 10. And then from dimension of 2 to 10, again from row and column, you can make it 1. And 2 to 10 to 2 to 9, you can again put it as the 1, and then just put the IM show here. Then with this command also, you can make the binary image and see that what is binary image in the MATLAB. Now, then after generating and importing the image and showing the image that you import inside of the MATLAB, In most of the application, we want to have the information about this image. Suppose we want to know some file detail about the pictures that we have. I advise you that you do it like what I have done here. Then you will see some fantastic data that maybe you will not be aware about it. How we should do this? The syntax is IM info and file name. We have other also data or other formats, something like file name and FNT or IMF info URL, which you can give the data from stream. Suppose you have some videos, you have some photos from some specific place or URL, you can also have that information. This information field displayed by IMInfo can be captured into the some structure value and can be used for subsequent computation. See, suppose for that ATA JPG, which that was my image, I have done the same test. See the data and things that you will take. Maybe some are nice for you that I make this from with my mobile, which is from Huawei. The model was here. You see the X resolution and Y resolution in that. Software that I use, they made the dates that I made this year and time. It's very important. Maybe nice thing is the GPS. Yes, GPS info, you can extract it here. You can see some other parts. Suppose color type are true color, depth is 24, width and height of my image, format of my, you see there are lots of data that you can, with the one small comment, you can get it. I advise you to test this. Even in your task for today, you should repeat all these commands that I put and send for me with your own image. But I think that is a nice experience for you to see that simple image that you have in your mobile. It has the lots of information. Then maybe that now one golden sentence, which there was from Einstein, that he said that one image can speak more than thousands of words. You will see that exactly that maybe thousands of words here, okay, and data. Uh, if I want to give you the table about this image, you can see that um, we have some data in IMInfo like this. Suppose we have the file name, which is name of, it can be name of file, internet URL, some specified. And if the file is not in the current folder, the character vector contains the full path name of the file we can have. We can have the file mode date, we can have the file size, format version, width, height, bit depths, color types, and so many useful data which you can extract from the simple image or whatever input image that you have. Let us see maybe one of the important uh, things in our MATLAB command. Let us see this command, which we call it whose. Whose command is that we want to see that how, suppose the matrix or that image is stored inside of our memory part. If after showing the image you put whose and this command just whose, you will see again some more data and nice information about the bytes classes about your image. Why it's important? Because you know that um, even we talk lots of so many times in our C language lecture that the main obstacle in programming is the memory size and memory allocation. Now, with this, you can see that how much memory you need for your image to store, and then you should manage it with the algorithm that you have for the real world. Because still, working with the laptops or computers, stand computers like this with uh, OS is not something that all people in industry accept it as the real world. In industry, people want their own OS, not something like this Microsoft, which is depend on various parameters to work. Then in that, if the OS is something private like that, then the allocation of memories also should be managed. This statement can help you to know the memory allocation and how your data or your image is stored inside of the memory. Uh, okay, I tell you that instead of image show, you can have IM tool also. And the format is something like that: IM tool I or IM tool I and range. You can IM tool RGB, BK, like that. You can do these syntaxes. And suppose if you do the same job that I have done with this, you will have one application or one um, something like tools you can open with the IM tool, which have some nice part. I can tell you it's very near to Paint in MATLAB in Windows, which you can do some job like that, something like cropping. If you want to do the crop, simply you can do the crop with this. But some other parts we have. Suppose if you want to know the information about your image and display the image information, you can put this part as I specified on the image and get the information, suppose width and height. Or if you want, suppose to measure the distance inside of your image, suppose from my head to eyes of that robot, from my ear to eyes of that robot, or from my shoulder to shoulder of the robots, and measure that how much distance you have. You can use this IM tool, which is very nice. It can be applicable in various part and various job also. But suppose if you want to know the pixel regime like that, you can see you can use uh, another tab inside of this app and also see the pixel in the individual part and see the value of that. I do the test again for the pictures that I enter initially for your course, and then you will see the pixel values as described here. Maybe suppose in because now what is our subject is just working with various command in image processing toolbox. Somehow it's happened that you want to work with multiple image. Uh, but you want to merge these photos together and using the sum function that we call it subplot. The function has three parameters, as you know, which they are separated with the brackets. The first two parameters specify the number of rows and columns to divide the figure. And the third one specifies which subdivision which will be used. For example, the subplots for 3, 2, and 3 will tell MATLAB to divide the figure into the 3 rows, 2 columns, and set the third cell as active. Let us see. Suppose I have this image, but uh, first attack is that I want to do the IM read figure and show it. Second is that I put it as the figure A. Figure B, I put it again, read it, and then show it as B. Okay. Now, if you want to show these two figures inside one window, I can use the subplot and use this command. Means that again, read image A, read image B. I put image A as author one, second one as my name, uh, just my name. And then with the help of subplot command, you can merge this and show them inside of the one figure. You will see that now my figure name is one, but previous one I have figure one and figure two name. Maybe when you want to work with the image, you need to do the writing job. I mean, image are written to the current direction using the I am right function, which has some syntax like I am right, name, A, and then file name. These commands write the data to the file, which is specified by the file name in your current folder. And I am right function supports most of the popular graphics files, something like GIF, HTTP, JPG, PNG, TIF, and that. And it's useful. Let us do some example like that. Suppose I want to generate one random binary image, okay, with the format of PNG. How I can do? Simply, first, I will specify one matrix, call it F, then generate the 1000 number. And then in I am right, I will put the F and rand.png. Simply, you can see this image. When you open the folder in which you are working, an image file name random.png will be created. And this is the result of these codes that I generate. You can see here. The format of this I am right is something like that, but we can also have some further work with that. With this, I am right f file name.jpg and then quality and q. Q can be some number, some integer number between 0 to 100, and it can be used to reduce the image size. Quality parameter is used to trade off between the resulting image subjective quality and file size, which is another use of this I am right, that you can work on quality of your image. Let us do it. Suppose I have the image that I show you, the first image, auto image, which is saved in my current working folder. And now we want to have the three different quality. One is that 75, something like default. 10 as the poor quality and a small size, 90 as the high quality and large size. Let us see what will be the code. Code is something like that. First reading the image, and then quality 50, 75, 10, 90, and then show it. Let us see the result. Result is this. Figure here shows the image for quality of 75, 10, 90, and you will note that the low quality image has the smaller size than the high quality. Maybe now, because you will see these videos on the stream, you will not sense the difference between the image on your screen. You should test it on your computer, and then you will see how the quality will be changed by 10 to 19. And what is the effect of this command for the image that I generate? I am right syntax also applicable to TIFF image and has the same format, just as you will see some more extension like resolution and parameters, and then they have that you can find it for the MATLAB help. Now, what we learned till now is that how we can input in the image, how we can show it, how we can do some small work like generating the random image, how we can use some uh, image viewer applicable application or IM tool and use some various part. Then let us review the type of the image that we have. Then we can continue for the image quality part. Uh, as we say, MATLAB toolbox supports four type of image with the name of gray image, binary, indexed image, and RGB. Some brief description I bring for you. The gray level image, which referenced as the monochrome image, they are using the 8-bit per pixel, where a pixel value of 0 corresponds to the black and the value of 255 is correspond to the white one. An intermediate value between 0 to 255, we can call them as the gray one. They are enclosed as the 2D array of pixel with the each even each pixel has the 8 bit. The next type of the image are the binary image, which this image use 1 bit per pixel, where 0 usually means black and 1 means white, and they are represented as a 2D array. The small size is the main advantage of this binary image. Another one is indexed image, which they are very important. These images are matrix of integer x, where each integers refer to the particular row of RGB value in the secondary matrix map known as color map. And RGB image are in them, each color pixel is represented as a triple containing the value of RG and B components. In MATLAB, an RGB color image corresponds to the 3D array of dimension m by n by 3, and m and r are the height and width of image, and 3 is the level that we have, level R, level G, level B. Purposefully, again, I describe you this image information or image type here to know the different type as well as the uh, difference between the image one. Okay. Let us continue with the image quality, which we know has a term of spatial resolution and quantization that we reviewed before. In this, the pixel density over the image, the greater of the spatial resolution, the more or the pixel used to display the image. The spatial resolution is expressed qualitatively as dot per inch or DPI. The image resolution, you know that it can be using the IM resize function, and these commands something like IM resize 1 divided 2 uh, how's the image size, and this done by taking the matrix from the IM size x1 2 means all the pictures are represented to produce an image of the same size as the original, but with half the resolution in each direction. Other resolution change can be done by using the desired scaling factors, commands IM resize, and change the image resolution by half or something like that. Let us test. It's better option for us to test this command. Very simply, I have done the uh, example here, as you will see. First, I read the image. Second is that I'm showing it with the name of figure. And then now I am resize and then put it 2 by 2. This is something like that. I change the quality of my figure by 2. What about other things also we can do? Suppose 1 divided by 4 and 4, as you see, and then I store it inside of the new image. I think you should test this image to see the difference. I can see the difference here, but maybe there is some problem with nets from your side that you cannot see the pictures uh, uh, clearly. Okay. This program is something that you can test, means that you can test it divided by 8 and tell me the difference, which is inside for your task. Number 4. See, this is the part that we stopped that was regarding the using the image resize and changing the quality of the image, which you will test on your system on your own image. I will review once more that we had 3 main critical comments till now. One was image, which create and display the image object. Image SC, which is scale and display an image, and IMShow, which is display an image. Now let us work with the type of the image, something like single gray level, which image quantization uh, can be described as mapping process, which in that groups of data points, means that several pixels with the range of gray levels are mapped to a single point, which we call it a single gray level. An image can be requantized in MATLAB by using the gray slice function. In the following part, what I have done, I use the set of commands which reduce the quantization level to 64 and displays the image. You will see that after CLC and close all, we just clear the data and close our previous window. Here I read the image from a specific location. And after that, with the help of the gray slice, I start to have the gray level, single gray level with the 64 level. And then I just show it. And result is something that you say. Pictures, I don't know what is the quality on your side, but if you run it, you will see that it's become darker. Some filter like that, it's happened on the pictures. Then if suppose I want to put it with the 8, it's become more darker, as you will see. And with the gray level of 8, the result is something that we show. But till now, what we can do, we can have some conversion that just in brief, I try to bring you the command, something like intensity image to index image. You can use grade 2 IND. These two, actually, in MATLAB's command, it's something like conversion. IM to binary means that image to binary, image to double precision, image to 8-bit unsigned integer, image to 16-bit unsigned integer, indexed image to intensity image, matrix to intensity image, RGB to gray level. You will see RGB to index image. These are the conversion which you can find the good example even on inside the MATLABs if you want to review them. But uh, till now, what we work, we show the figure, read the figure or image, do some small modification on that, store it, and then show it. And some conversion also we have done. Now let us go for our image enhancement lecture that we had last time and talk regarding the histogram as one of the important and nice tools that can help us to analyze the figure or pictures better. Histogram of gray scale image represent the frequency of its gray level occurrence, and it's a graph indicating the number of times each gray level occurs in the image. In a dark image, gray levels and hence the histogram are cluttered as the lower end. In the uniformly bright image, gray levels and hence the histogram are cluttered at the upper end. In a well-constructed email, gray level and hence the histogram would be well spread out over the much of the range. Let us see what we mean. Suppose the pictures that I give you, that JPG, my own image, it has exactly this output. If you run just the I am hist command, you see, I am hist will give you the histogram of that image. The three main operations performed on the histogram, and including the histogram stretching, histogram shrinking, and histogram sliding, and all these operations I will describe for you here. But in MATLAB, the histogram can viewed by using the ImHist function, and the example is based on the pictures that we start our today lecture with that. It's something like that. We will talk more regarding this histogram today. As we talk, IM is the function. Suppose if you want to test it in another pictures, I tested suppose in uh, pictures of POUT. Okay, pout.tif. Another format, another pictures also. Same job, there is no difference. Just first you will read the image, after that, I am his I, and you will see this. But the difference between this figure and my figure is something like that. See the difference between histogram. I think the uniformity of this histogram is little bit better. My figure was um, variance or value that I have in my histogram that was spread in my photo. But here you will see that it's a little bit centralized between around, I think, between, you will see after 50 and below 200, they are the range of the data that you can see the you can see the values which represented in the form of histogram. Uh, we have one command which we call it hist EQ, which in test, which in this command, you should notice that how the intensity range is rather narrow. It does not cover the potential range of 0 to 255 and is missing the high and low values that will result in the good construct. Now you can call the hist EQ to spread the intensity value over the full range, thereby improving the construct of image, and then return the modified image in the value of suppose I2. What I mean that you can modify some image and again return it back. Let us do this job together. First, I read the hist EQ of image I and put it into the I2, which is equalize I and output in the array of output. And then I show it here as the I2. Uh, this is something, some jobs that at the initial point I have done. And here you will see that it's high and low value with the good contrast are shown here automatically. There are some methods, also some mathematical methods that you can work better and maybe more specific on the image. Here, there are some internal things inside the MATLAB which it do it automatically. I will give you one good notes regarding this part that you will read it and understanding better how it will do inside of MATLAB. But histogram scratching, it's one technique which is known as the input cropping and consists of some linear transform as the curve that I show here. In that, it's a scratch the parts of the original histogram so that its non-zero intensity range occupies the full dynamic gray scale. If the histogram of image is cluttered at the center, it can be scratched using the IM adjust function and with the following comments that I show here. These comments here inverts the gray value of image to produce the result similar to the photographic negative that we had before. Yeah, you remember previous time before this digital camera, we had some uh, negative photographic negative which it generate, and then from that they will make the photos. And in this histogram scratching, with the command that I tell you, we will require the user inputs. An alternative approach is to use the histogram equalization command, which is entirely at the automatic process that already we discussed. Here in this photo, you will see the low and high value and low and high value in X and Y direction, which give you to do this scratching. Let us see and do this automatic job on my photo and spread it and scratch the histogram. You will see that um, suppose equalization commands with the hist EQ I have done here on my photo, and then you will see the difference between these histogram and the previous one that we have. I think you should test it here, even on my image. Some change I can see. I don't know how much you can see on your PC, but this affect the contrast of my image. Another things in histogram was histogram shrinking, which in this technique, which as they call it as the output cropping, will modify the original histogram such that its dynamic gray scale range is compressed into the narrow gray scale. An I'm adjust function can be used for this histogram shrinking. Let us see uh, one more part, which we call it histogram sliding. And in this technique, we will consist of simply adding or subtracting some contrast brightness value to all pixels on my image. The overall effect is an image with comparable contrast properties, but higher or lower average brightness, respectively, IMD and I'm subtract function can be used for the histogram sliding. When implementing this histogram sliding, you must make sure that pixel value do not go outside the gray scale boundaries. An example of that is here that I show here for you. You can see. First and second line is CLC enclosed, and I read, and then I show, and I put the label for my output as the original image, just to know it. With the second one, I assign some bright add value as the point to, which in that I wanted to add this brightness to my image and then show the histogram of that. In the next line, figure I am hist A, just the original image histogram I shown. Then at the next, I add some value of B to my image, and then I show the new bright image as well as new histogram. Then now you can compare that my histogram is going with the right side of axis, and also weightage or the number of the line my right side is more than previous image that we had. This is the effect of how we can do with um, histogram command and how we can work with this. In the example, the image is brightened by adding the 0.2 to each pixel values, and figures also shows the original uh, with a histogram as well as modify range with that. How it will use, suppose you have one application with images little bit dark, you want to make it little bit brighter. You can use this technique. Mainly, these techniques are used when we want to do this some edge detection job, or you want to specify something inside of your pictures, which we will see later. But here you can see the result of last code that I shared, and you can compare them together. As we say, we have various type of the image here. Uh, and somehow in your application, you need to convert from one type to another type. One of the good command which you can use and convert, do the conversion between the images as convert to binary image, where IM as the image to BW means binary. And syntax is like that. I am to be, I am level, and like that. Same job I have done for the figure that we have. I am to BW, A and 0.4 as the level of the binary, and the result is what I shown here. You will see that now if the background is removed, there is no background compared to the original image, and even I become more highlighted in this figure, then maybe this can help us for detecting some specific part in our image. Thresholding is also used to remove some unnecessary details from an image and concentrate on essentials. It's also used to bring out the hidden details in the case the image of interest and backgrounds have similar gray area. And this thresholding can be further classified as single thresholding and double thresholding. In MATLAB, single as well as double image thresholding can be done. Let us see more that single thresholding in the gray image is turned into the binary image, means black and white, by first choosing the gray level of T in the original image and then turning every pixel black or white depending on the whether its gray level is greater than less than T. Thresholding is the vital part of image segmentation where users wish to isolate objects from the background. To convert an image F into black and white image G with threshold of hundreds, the command MATLAB is G equal F greater than 100. And then the following example read the image. Suppose one image of penguin gray I had before. And we can display both original image and the image which is generated after the thresholding using the factor of 70. Suppose I put the image of threshold image of 70 here. Uh, Now the effect of this you can see later on these photos that I show you here. Same initial photos that we had, and then now with the gray threshold of value, you can see the difference and act of first initially to the uh, black and white or binary one, and then second one is that working with the gray threshold job. Then we review the threshold. Then if we want to use the morphological operation to estimate the background, we can also use the command which we will read here. Then notice that the background illumination is brighter in the center of the image than the bottom, and by using the IM open function to estimate the background, you can use that. To see the estimated background image type, then you can use the IM show and see the result. Let us do the same example with the 15, 35, and 50 again. And then you will see that the difference and act of this command on the original image that I have. Again, I have some change. I can see, I don't know how much you can see on your side. But after running this, you also will see how it will change the image. Now I think you can try this. You can put the IM sharpen and then see the result as one of the tasks for you. Okay. Sharpening also is the powerful tools for emphasizing the texture and drawing the viewer function. It can improve image quality even more than what is achieved through the upgrading to the high-end camera lenses. Most image sharpening software tools work with applying something called unsharp mask, which actually act to sharpen an image. And the tools work by exaggerating the brightness difference along the edge within an image. Note that the sharpening process is not able to reconstruct the ideal image, but it creates the appearance of more pronounced edge. And the commands which you can use for sharpening is I'm sharpen and then again act on the good photo. Then you can store this value on the one matrix and then it returns the enhanced version of grayscales or true color, something like RGB inputs. Okay, where image features such as edge have been sharpened using the unsharpen masking method. Then you can use another formats for this sharpen as the I'm sharpen a name value, which in that you can use the sharpen the image using the name value pairs to control the aspect of unsharpened mask. This function we can see uh, on the same photo that we have. Just sharpen I use, and then the action I think again it's not visible from your side. But if you see, it's make it sharpen and then background is little bit going back. Then in sharpening, you can also specify the radius and amount parameter in the I'm sharpen function as the given in the example below, with the radius of 4 and amount of 2. And you can check on the previous figure because that is not visible. I didn't put the uh, real example for you, but in your task, you should do it and work with that. Okay, then there is one type of representing the data which we call it surf. And in surf, we are going to display the background approximation. Okay. The surf function requires the data class of double. However, you first need to convert the background using the double command with the help of this statement that are written for you, and you can test it on your system. Maybe an example of indexing syntax to view only 1 out of 8 pixels in each direction. Otherwise, the service splice would be too dense. And the example also set the scale of plot to the better match range of unit data and reverse the y-axis of display to provide a better view of the data. The pixel at the bottom of the image appear at the front of the service plot at, as the figure that I show here. Maybe one example with the rice I have done here. And you can also test this more analyzation about these jobs later we can do. Now, just our aim is that working and become familiar with the comments inside of the MATLAB. Then, as the task for, I want that you do all the jobs, test all the codes that I have done here, and send it by the PPT. First image as ATA, it can be your, but ATA 1 is the picker that we have for our lectures. I know I put it there. And then you should send it till next lecture. Please review all this PPT, do the comments. If there was the problem, read the error. If you didn't understand the comment, read the help from the MATLAB. I purposefully test all with my image that you see that the code don't have any problem. And I give you the real output. Please see and try to analyze and have some good concept regarding the image.